process planners. In the early part of the manufacturing stage, when they receive the part, the product design from the engineering team, what they do, they start with, identifying based on the manufacturing process, based on the CNC machine available and which where exactly this is going to be machined. So the process planner come up with the bill of process actually, right? During the time, they are also responsible for building the stage models. Basically, define the shapes or model the shapes that needs to be machined on all the different stages based on the bill of process. At the same time, they do author all the manufacturing information in addition to this, the shapes on the stage models, and then they output the work instructions that are typically either the the 2D drawings, which are sent to the downstream. That you see here, the consumers of the stage models are the CNC machining, the machining programmers, the inspection team, the fixture designer, the line optimization team. And they also work very closely with, the process planner. Basically, there's a collaboration. It takes place between the process planner and the downstream. The machining people can come back and say that, oh, there's some operation can be eliminated because I'm using, we're having the, 5-axis machine, for example, or do you want to add more stages? They kind of collaborate, on the different operations that are required to go through the machining processes, right? And we have seen customers that are using, all the stage model and the downstream machining processes in a native mode and also in a managed environment, right? This is on a kind of a high level. Then if I go one level deeper into this, what exactly is going on with respect to stage models. The center part of the picture basically shows the stage model authoring process, right? And then we have the lighter shaded boxes that basically shows the references they have, the basically information they have to define the stage models, although they model the stage models. You can see on the top, they have the bill of process. If it is a process planner, the same person will have information to the bill of process, and then, they define the stage. They do have an access to the engineering data. The data can come with PMI. Sometimes they will have 2D drawings that, from the engineering department. And also on the right-hand side on the top, you can see that it's a very important part of it. They do have access to the, the huge amount of engineering data book, offset table, the tolerance take-up tables, etc., because that is what they need. If the part needs to go through, say the roughing operation, based on the shape of the feature they're going to be machining on a particular stage, they refer to the engineering table, they identify, okay, what type of tolerance and surface finish I need to use for the roughing operations, right? And, similarly, if you go into the semi-finish operations or the finishing operations, right, at the bottom one, you can see that once the stage models are defined, and then the shapes are modeled, and then added all the tolerances, surface finish, they do output the work instruction drawing, typically the 2D drawings that are passed on to the downstream the machining or manufacturing processes, like machining and inspection and fixture design. So that's a kind of a one level deeper into what exactly going on with respect to stage model process. Again, I try to simplify it. There are a lot more things going on with respect to the, the information they have in hand to define the shapes. But I try to simplify, just for this, just to make sure that, I'm able to convey where exactly this particular product fits into the process. This is again another important slide. We should know who are the personnel involved in the stage modeling process. I identified 3 different customer scenarios. On the top, again, you can see that, if you look at OEM and tier 1 suppliers, obviously it is starting from the manufacturing, it is part of the manufacturing department, and the process planner is responsible for defining the stage models. And yeah, they're responsible for defining all the bill of process. At the same time, they do model the shapes, define all the operations in a 3D model or maybe in a 2D drawing, right? And that are then passed on to the CNC programmer. The second scenario, it's the same. I've seen some customers, even in OEM and tier one suppliers, they have a specialized CAD users, because if they need to model all the operations, in 3D models, you need to have, good experience on the CAD, modeling tools. So they do, they basically, once the process planner finalize the bill of process, they send it to the specialized CAD users, who are sitting in between process planning team and the downstream, say, for example, the CNC programming team. They model them and then they give it to the CNC programmer. The third scenario is the small to medium, the machine shops. We have seen one person does the bill of process, coming up with the process planning, modeling the stages, generating a CNC program. So here are the three different, scenarios, and if we should know who we can talk to, in a OEM or a tier one, or even in these small to medium machine shops. This is another thing, you might be wondering, why do we have this special application? So we have been, hearing a lot of feedbacks from the customers, or the input, the requirements. So we have identified, how this new application can help the challenges faced by the manufacturing engineers. Some of you might have definitely gone through or worked with customers who might have come back to you with, okay, how can I define the shapes in a lot more easier way? So typically the customer that are using, the CAD applications, are the methods that are provided by number of CAD applications in the market we have, are too complex for the manufacturing engineers, for the simple reason the process planners and CAM programmers, I wouldn't say CAM programmers, they do have to an extent the CAD knowledge, but if you look at the process planner, they have very minimal CAD knowledge, right? For them to learn the complex modeling tools, the way the assembly handles, the wavelength handles, it's too complex for them. And so because of that, the process planner end up preparing 2D drawings, basically for capturing the shapes of the stages, the shapes, even all the tolerance and surface finish, even the offset required, depending on the different operations. It makes it difficult for downstream consumption. Actually, if they provide 2D drawings, the CNC programmer needs to model them actually, right? And then so obviously it's very difficult for them. The third point you can see here that there are a number of different ways I've seen customers, modeling those stages. Some customers build the assembly as a container, right? They can build all the stages in an assembly. I've seen also a customer a single part that contains all the operations. Basically, they model all the different features. Now even our own customers are taking advantage of the feature group to define them. They define the stages, model all the shapes. At the same time, they're managing all the stages. If you have a part that contains all the stages as different, features, then you need to group them. And if you have to send that particular feature group to the downstream, then obviously you need to extract the geometries, and then imagine how that needs to be managed if the customer is using the team center, right? If a single part can go through tens of different stages, managing all those stages are also very, it's basically tracking those stages and the changes going through between the design model and also the stages are very painful. We're also hearing from customers the no associations of PMI between the product design and stage model. As you saw in my earlier slide, the customers have an access to the PMI coming from engineering data. They do reuse that some of the PMI in the stage model and then repurpose it, things like that. So, and at the same time, when the engineering data comes with a new change, the PMI is changed, and obviously you cannot update all the stage models. So that's another challenge. And the second last one you can see here, the consumption of stage model and downstream process, the bill of process or even the CAM involve a lot of manual work. One good example I gave was if you are building all the stages of different features and grouping them as a different feature group, if you have to extract them and send it to the downstream and managing all the things are very manual work. There are customers, for example, for inspection and fixture design, of a particular stage, they are dependent on CAM application to produce in-process workspace. Obviously, NX CAM produces, the great quality with the great quality, the in-process workspace. There are some different CAM application. They don't really support this very well. So obviously, that's another painful area. So what we are trying to do is to front load the stage modeling process in the early part of the manufacturing, processes, drive every downstream application on 3D model. So that is the main purpose of this applications. So looking at this, so what we have done is we basically automated the entire process for defining the stage models, creating the shapes, and the management of all the stage model that that needs to go through for a particular engineering data. So this basically involves 4 different components. The first part you can see here is the stage model definition, creation, and management. The second part is the model-based definition of stage models. The number of customers I talk to, one of the reasons why they want to do 3D models is obviously for easy consumption of in the downstream. At the same time, to be able to capture all those information in 3D, like through PMI or the new approach is a model-based definition. The third part is the consumption of stage model. We want to definitely make sure that the stages you define in this new application can be directly consumed by downstream applications such as machining or inspection and fixture design. The fourth one is another important aspects of it, the user experience suitable for manufacturing engineers. We've introduced a lot of new capability, which I will show at the end, where you can see how this is so easy for manufacturing engineers to use and get their job done. We looked at a lot of different aspects of how simple it should be so that the manufacturing engineers will be able to come out of 2D environment, build them in 3D, capture all the necessary information and manage them, and of course work with the downstream team. So let's look at each one of them in detail. The first one, the stage model definition, creation, and management. And as you see here on the right-hand side, here's an example of top-down approach I took. I'm going to be using the same part or one of the parts, which I'm going to show the demo. So this application is going to help the manufacturing engineers to define all the stages, create stages, modify stages, very quickly. I would rather say that in a lot of simpler ways than what they do currently. There are a lot of new tools like interactive stage model set creation. You're going to see that we can add a stage, we can delete a stage, insert a stage between operations, and things like that. And of course, it does leverage a lot of modeling capabilities to define the geometrical shapes. Obviously, once you define a stages, you need to model them, right? Basically, if you are using a top-down approach, you start with your product engineering data, and then you start going through the decomposing feature. That's why you would use synchronous modeling technologies. If you are using a bottom-up approach, you're going to be starting with a cast model and also the product design. Then you're going to be adding features, using some modeling technologies. So it does provide access to the modeling tools inside the stage model application in order to define the shapes more efficiently. We have also introduced this new compared geometry between 2 stages. You are going to see that in probably next week, the new compare tool. This is very much applicable to our stage model. If the designer wants to see what is going on between 2 different stages, what I got for this particular stage I'm working on, they basically did look at before and after stage. So basically, a lot of different ways the customer built, creating an assembly, wavelength, and all the stuff. We have simplified that process, and then that can help them to eliminate all the manual modeling method that they go through currently. And obviously, it is going to provide the greater productivity improvements to our customer base. So I'm going to look at the demo of this one. So I do keep an eye on the chat window. There are no questions so far. All right, so you can see here, this is a simple bracket. I do have 2 examples. This one I use for demonstrating the top-down approach. I am starting with my engineering data. that contains PMI. You can see here, this is imported from the different CAD product. Obviously, if you are using NX, if you are getting an NX model file, it is good. Even other, even you will also be able to bring in data from different CAD systems through STEP or IGS normal import process. You can use inside this application, use that as a starting point. So in this case, I do have the JD associated body, and if I go look at my model views, we can see that I have different model views. The top, the top side pockets. Then you can see the another, different views, and also look at the overall dimensions. So it does contain a lot of model views with the PMI information required. So this application is available as part of the manufacturing group. If you go look at this one, you can see the stage model. If you select this, basically what it does is it'll provide you with the home tab. You can see the set of functions that we have grouped them as part of this application. We have also exposed some modeling tools. Basically we, provided the most commonly used function. Obviously, you can also configure this tab to add more modeling function if you want. It does provide the PMI analysis tab. So in this case, I'm going to start with the starting part of the process is to create stage. When I click on the stage model set, that's the first function to start with. It basically takes the product data that I have on my screen. You can define to start with, whether the number of stages, you can start with 1, or you can also start with, 6 or 7. If you have a bill of process information, looking at that, I need probably 15 operations. I can simply create the 15 operations and I can start with that. It also provides a folder where you want to create all the stages. I could start, say, design model stages 4. In this case, I'm going to start with one stage here. So when I do this, you can see that it automatically switches to the stage model navigator. This is a new navigator you would see. Basically, I'm going to explain this later. So basically what it does is, in this case, it creates a new stage model set that is going to include the product data I started with, which is the design part, and also the new stage I created here. If I go to add more stage here, so if you want to add a new stage, you can just say click on this particular stage, and then you can add a new stage here. So in this case, I can also give there's a different name to this, and I can accept this. It's going to add a new stage there for you. So you can see that, it basically, the stage model set consists of the design data and all the stages that goes along with this design data. So everything is in a single, in one area where you can access all the information about the stages. Actually, I'm going to explain this, the future navigator and the future contents navigations in detail going forward. If you want to delete this, you can actually also go and just simply use the MB3 button and then delete that once you don't want this. So in this case, what I do is I'm going to start with this one. I'm also given with an option. I can edit this. You can also you can give a name saying operation 10. If you want, you can also provide some information to this, saying that you want to mill to start with, mill 4 pockets. For example, on top side using datum. So this is the information you're going to give it to the downstream, process team. Actually, add this note here. You can change the name of the stage, so you can see that changed. So in this case, what I could do is I could start with the first step of the process is to take a reference of the product data. So you can see this. We can link geometries. Obviously you have access to all the information, curve, point, datum, sketches, face, and body, right? I can start with my product data. So this is my the first operations. So in this case, what I'm going to show here is, okay, I'm going to be probably machining as a final operation this top 4 pocket that I've identified as part of the description also. So I could quickly go into group faces. I can add new color to this, saying that this is what I'm going to be machining here for this particular operation. Okay. The next one, I can add a new stage, which is called, I can go into the navigator, add a new stage saying operation 20. So in this case, I'm going to say mill large pockets. On top side using datums D, E, and F. Example, right? So you can provide that information. So it adds a new operation for you. Now I can make use of my multi-window layout. So I can see that I have the engineering data. I have the operation 10. Now I have the operation 20. So in this operation 20, obviously I'm going to be referred to the stage, from the information from operation 10. So I can go into the link geometries. I can select the geometry from operation 10. So it's going to provide that for you here. So here I could go and basically delete the pockets because these pockets are mentioned in my operation 10. So I can go and delete all those pockets here. And then I can identify here are the the top pocket I'm mentioning. So I can go and pick all of them. And then I can also just say identify this color by the color the machining features. So like this, I can go into operation 30 again. So going to add a new stage, which is operation 30. I can add some description to it, whatever you need. I can go and accept this. Then I'm going to be using my multi-window layout. And then so basically going through the similar process like I did for operation 10 and 20, right? So click on this, I can select the operation 20 information. And then obviously I'm going to go delete these pockets, the center pockets here. And then I can identify the faces, basically saying, so I got to go pick all those holes equal radius here. The radius, so pick all of them and then say I'm going to be identifying that as the feature that I'm going to be mentioning here. So you can see that I went through my design part, went to the operation 10, operation 20, and operation 30. So this is how I can continue on, continue to build all the different stages. Obviously, I don't want to take up too much of time on this similar process. So I do have the model that I have built. So basically you can see here, start with the design model. I have, all the 60 different, basically 6 different operations. So going through the operation 10 through operation 60, you can see all of them over here, right? In the operation 40, I'm mentioning this, the top pocket here, and then obviously, and also finishing up the center pocket, you can see. And then the operation 50, I'm mentioning this because I need to, of course, I do need to machine this to a smaller shape in order to get to the final shape in operation 10. And then I have operation 60, basically from the cast model, I'm mentioning the top datums actually. So you'll be able to basically define all the stages that are the way I would demonstrated, right? Defining all the stages and then taking information between stages is a lot easier now. And then obviously you can, in this case, I went through the synchronous modeling technologies to decompose features to get to the casting model. Here I want to show, obviously I'm in operation 60 here, and I do need the cast geometries, So here what we do is we do provide a new function which is called the derive stock. So sometime you can use existing 3D model based on the engineering data. You can simply offset geometries to define that as a stock for you to start with, right? So we do have this new function derive stock. So in this case, I could go and select my final shape in this case, and then I can also provide, we can obviously select, let me click on this one here. So if I go into the setting, I'm going to select the geometry, the engineering data, and if you go into the settings, you can provide, how much do you want to offset on all over the side. So basically on X and Y's and Z directions. If you want, you can see here on all the 3 different directions, you can key in all the clearances. Sometime along positive X, I will give you more, thickness than the left side of the X axis, right? So you can define different thickness. It also gives you the stock size and the blank size. So if it is a shape something like this, I would use the block as a derived stock. If you have a shape something closer to cylindrical shape, we do have the cylindrical option there. So you can go and select this. I can simply say here, this is going to be my derived stock. When I continue this one, it does create a stock for me as a last stage. You can see that you have a derived stock coming, added as a last operations in this case, and the navigator basically.
Right.
So you'll be able.
I'm going to interrupt your flow a little bit. Just there are a couple of questions popping up, and I don't want them to disappear off the chat window, and they are relevant to your demonstration. So one question from Luciano is there any automatic option to inherit the body resulting from the previous operation without having to manually link the body? So
that's a good question. I think we have, after showing this demonstration to a number of customers, not only taking the geometry from the previous one, the customer also requesting, okay, why would I need to manually delete those features? Can I build some new rules in there? I know that for this roughing operation or finishing operations, I need to, I'm going to modify certain features. So we are looking at our new technology that you saw last week, actually, to build the rules and run the rules to do it. But right now, obviously, it's all manual. You have to manually link the geometries from the previous operations. We definitely looked at that also, even without going through the rules. In fact, our initial prototype involved basically taking the geometry from the previous operations. The customer came back and said, how do we decide whether I need the solid body? Sometime I would need sketches. Sometime I need some, curves. It's very difficult to do that. That's why we kind of left it to the users to decide manually. But we are looking at automating that going forward. Yeah.
Okay, that's perfect. Now the question is, how does this all? Maybe you're going to cover this in a minute. Is about any links to Teamcenter part planning. And I don't know whether you've got that. You're going to talk about that in the future of this presentation, or?
Yeah, I don't have the future roadmap, but that is definitely part of our plan. Right now, what we are looking at is to manage all those stages in Teamcenter. Obviously, we are in discussion with our MFE team to see how this can be associated into the process planning, right? If you're talking about the part planning technology, yes, we are looking at automating that whole process. Yes, that's a much more tighter integration you would see going forward. Right now, this can be managed easily in Teamcenter. Once these data are in Teamcenter, I believe the part planner takes information from Teamcenter. They'll be able to do it manually, but we are trying to make it, in an easier way for them to consume them in the part planning.
Okay. Yeah, it's a good answer. And then one more, and then I'll let you carry on, and then we'll get to Silva's question in a couple of seconds. And then Andres is asking if you can, the workflow you've taken is from finished part to stock, and the question is, do we have a way of processing it, doing it the other way around, and actually managing the process?
I have the example to show that. Of course.
Okay. There you go.
Right.
Perfect. Yep. And yep. Sylvia, we'll get to your question. We'll let Dax carry on, and then we'll come back to your question in a couple of seconds.
All right. Right. So yeah, basically in this one, I wanted to show a couple of things to, basically demonstrate the top-down approach to get to the derived stock. I think I was on the derived stock function. Right now, obviously the function I used was to taking the reference for the product data. I've seen customers having all those stocks information already in a database, right, in Teamcenter. So you will also be able to, instead of going through the derived stock approach, you can also go into the library, bring in the necessary stock you need for this particular part, and also be able to adjust the sizes if you need. So you can do that. So in this case example, I used the derived stock. The other example is, obviously, I try to show this one to you. So here you have the design part on the right-hand side, and I have the cast model. Again, I cannot use the customer data, but we try to showcase how we can build a bottom-up approach. So if you look at the design part, typically the customers they do have all those features. You have the holes, the slot, everything. The designer build them as the tool bodies in order to subtract from the cast model. So basically what they do is they start with the cast model, they build the cast, they build all the tool bodies, and then come up with the final shape. That's what you see here. If you go look at my the part navigator for the design data, we can see that I do have the tool bodies. You can see here are the different tool bodies I used, and then I do have another set of tool bodies. Again, I try to simplify it just to show how the whole process works. So the manufacturing engineers are actually provided with the cast model, the engineering data, the final finished model, and also the tool bodies. That's what they have to come up with the stages, different stages here. So definitely I can use the same information. So what I could do is I can go into my, again, the stages. So if I go switch to the stages here, obviously I can even name this as a cast model, right? So I'm going to start with this one. I can add a new stage here, say operation 10. I'm going to use the multi-window layout. I think, yeah, I've seen comments on this multi-window. It's very useful here. A lot of different things that we introduced earlier. It's very useful for the stage model application. I'm going to show you. So obviously I could, in this case, I'm going to take the reference of the cast geometries. Obviously that's what I need. And I also need the tool bodies, right? If, sometimes I've seen customers, they either have the tool bodies, most of the time for this kind of a case that they do have tool bodies to start with, or you can also bring in sketches they use to build all those different features actually, right? So what I could do, I can go into my design pod. The other thing to note is while I'm in the stage models, you can see that the navigator automatically switches. The moment I select one of the stages, you can see that it goes to the stage model application, and also it shows all the stages here. So when I click on this, the design pod, you can see that it automatically switches to the pod navigator and other options. So yeah, we also took care of it. You don't have to worry about manually switching, between the application, when you're working on the scenarios. So now in this case, I can get back, I can show all the tool bodies required for my operation 10. And then maybe I can switch off my main body. Similar process, very easy. I can go into now the stage models, link all the bodies. So these are the bodies, right? And then I'm going to come back and then use a simple subtract options. Going to click on this one and then select all the tool bodies and subtract it. So obviously you can see this. We have all the tool bodies are linked here, and also the final subtraction body here. I can immediately go and change the color of this one. Right, so that's what I'm mentioning. So if I go in, I can add another operations. Operation 20. I'm going to use my multi-window layout, and then I'm going to be linking this time the geometries from here. Right, this is another good example of the the cases. Someone asked for, why can't I take cast body here? Yeah, I could have taken it, but I also need some information from my design part. It's very difficult. But I have also seen that it's not necessary that I would always use the information from a previous operation. Some customer cases we have seen, they do link, not necessarily the previous operation, the link from different stages into the particular stage they're working on, right? So that's why we kind of left it to the kind of a manual approach for now. Right, so I can take the body from my operation 10. I can go into my cast pod, or the design pod, sorry, and then I'm going to get back my tool bodies for the second operations, come back into my operation 20, and then I can link all the bodies. And then I can simply go and use the subtraction tool. Again, don't think that, okay, this is only subtraction. You can also build the sketches. All the modeling tools are available to you. Sorry about that. Yeah, so you can see here all the modeling operations are available to you. You can, if you want to create a sketch, you want to build your own curves and stuff like that, you use a revolve, or you want to even use a complex surfacing tools, it's all available to you. You can also see that if you go into the insert, you can see all the modeling functionalities are available to you, right? Don't think that it is just used for synchronous modeling tools, right? But what we have done is we kind of simplified the whole process of building the stages, accessing information from different stages, and of course you can start working on the shapes you're going to build on. So in this case, I'm going to simply go and select my tool bodies, and then select all those. Select the target and the tool bodies and build my shapes. So this is how you could go ahead and build different operations actually, right? In fact, I demonstrated to one of the automotive customers, 2 weeks back here. They had a similar example. They said the product engineers are giving the design data with all the tool bodies, and we have also, give them the cast model. Can you show me this? We were able to build this. It's a simple model, but I think the case we got from them was complex crankcase. We were able to build them, show them how easy it is to build the entire stages very efficiently. That's a goal here. Okay, all right, and so that's a kind of example. So basically, you saw that building the stages either through the top-down approach in my bracket example. In this example, you saw the bottom-up approach, where you have the cast model to start with. Okay, I'm just taking a time on it. Okay, so you do a shortage of time. All right, so now going into the next one. The next part of the process is, okay, now I define all the stages. Now I need to author the PMI, or the manufacturing information, right? PMI is one way of capturing information, especially for the customers moving towards MBD approach. So we have introduced a new function here, which is called reuse PMI, which I'm going to show it. Basically, you will be able to reuse PMI from the engineering data and then repurpose it. And also it is associated to where this PMI is coming from. So that's one approach. The second one is, obviously you have seen this demo earlier, the NX1953. I'm going to show you an example of how the rule-based PMI is going to help automate the PMI creation on my stages actually. So I do have an example on this to show that. And of course, the stage model specific rules. We have also provided around 11 stage model specific rules out of the box. We are going to obviously continue to enhance or improve the number of rules that will go into the out of the box rules. But yeah, here are the important capabilities. So basically, to capture all the manufacturing information on 3D models. We have seen customers, especially in aerospace, even in automotive customers, they have been asking us to help them with the stage models, capturing all those PMI. And you also saw in my original, in the initial slide where the rules are why it is important. If it has to read all those tables, right? The stock tables, the offset tables, or the tolerance tables. It's very difficult to refer to them manually. So we can capture all those information here. So based on the geometries, based on the operation you are doing, it is going to select the right surface finish and tolerance for you, and and that you can use to author on the stages models actually. So I'm going to show the demo of this one too. So just to start with, I'm going to go back to this example here. So you can see that same example, I have built around 6 different operations. So I can go into my stage one. The first one I'm going to show is a new reuse PMI function. So when I select this one, so basically I'm machining these 4 pockets that you saw earlier. Now I need those 4 PMIs, right? So what all I need? I need the datum G and H. I can immediately select this one. So it gets populated. You can see here I need the H. I also need those other feature FCS informations. When I accept this one, you can see here it is copied into my operation I'm working on. It is also actual PMI information. When I double click on it, you will be given with all those information. So typical PMI edit function you can see here, right? So it is actually the PMI instead of just a dump, just node or whatever the information for you. Any changes going into my design data. So you can also see that in the stage model navigator, you can see the up-to-date column. If I go and change in my design model, for example, this some information in my FCS, feature control frame, actually you can just change it to 020, for example. When I accept this one, you can see that the PMI I used consumed in operation 10, it shows out of date. You can also go look at, I'm going to explain this navigator later. So basically you can see these operations contains all the relevant contents, basically all the features. You can see the model views and also the PMI, right? If I go look at this, I can even select this PMI. Okay, that's the PMI which is out of date. I can simply go and update, click on the square box. You can see that it gets updated. You can also see the PMI, associated PMI, through the selection new function. You can see this highlight in inactive windows. If I go select this one, so if I go select this one, you can see this, where exactly, which are the stages this particular PMIs are consumed. You'll be able to see that very quickly, right? Either you can access it directly on the screen, or you can also use, the navigator to look at all those PMI. So this is another nice function. The another important one also, there's another new function you can see here, synchronize pan and zoom actually. So you can also see that when I zoom in, you can see which area I'm actually looking at. This is another nice cool functions, right? So some of the things we made it very easier for the manufacturing engineers, who are typically having a limited CAD knowledge, right? So I'm going to go back and then select this one. So now you saw this example where, okay, I kind of reused PMI, and obviously when I change anything, changes coming from design data, I was able to update it. Now let's look at operation 50 here, right? Now, obviously, I'm in order to get to the final pocket. Obviously, I'm machining this in two different stages, with the roughing operation, you can see here with a smaller pocket, and then obviously I'm machining the final one here. So in this case, obviously the tolerance information I would use would be different than what is actually needs to be done on the final operations. So if I go into the design models, I'm going to go look at the model views, go to the particular dimensional views. So I need those two dimensions here. So I'm going to come back into my operation 50. So I'm going to be using the reuse PMI. I need this PMI. I need this PMI here. And you can also see that these sizes are automatically adjusted. You can see this, the final shape is 7.568. And then here you can see the 5.768. If I go into operation 40, I want to reuse those PMI, and I'm going to select this one, this one. You can see here, this is where I'm going to be achieving the final shape with the tolerance. So I'm going to go back into my operation 50. Now, in this case, I do need to have a higher tolerance. So I probably start with 0.15 before going into 0.05 tolerance, right? So I'm going to go update this one. So I'm going to modify this one to 0.15 again. So you can see this is normal PMI information, right? So you'll be able to go and edit it. So this is what the customer typically do. They want to reuse PMI from engineering data and then repurpose it, right? That's what I did in this case with respect to tolerance information. Now, if I go and change anything here, obviously I don't want to update the roughing tolerance. Maybe I care about my finishing operations for this 0.05, but not for the roughing operations, which I want to control. So in that case, what you could do is we can also go on the PMI, click on the PMI, you can actually freeze update, use this freeze update function. When I use this freeze update, now if I go into my design part, for example, I'm just changing the tolerance to 0.02 or 0.04 maybe, right? Change that one here, and then I'm going to change this to 0.04. So when I do this, when I come back into my the stage models, obviously you do see that it immediately flagged that stage model set is out of date. Obviously, I do see in operation 40, I do have some PMIs that are out of date. I can simply go on update the operation team, so it does change. But in the operation 50, I don't want to do that, right? So you can actually also control the update process. Again, we left it to the user if they want to make sure that they want to update all the stages automatically, which is fine, but we have provided some control to the users to make sure that they are able to manage the manufacturing operations very well.
Okay. Now, Dax, I'm going to ask you to pause for breath because I'm conscious of the questions that come through. Okay. So one at the very early on was from Silvo, who said, did we look at using the existing progressive die wizard mechanism of strip development to create the associative stages. And now, given you're the product manager for both, I'm assuming
no, not really. We did not use anything, but the concept is similar actually, right? And the wavelength is the only part you would see in both. But otherwise, pretty much everything is, the capabilities involved here is completely independent of PDW, Silvo.
Okay. Yep. Then another one is a question. I'm going to try and take the question out of the points. Have we done any performance testing? I guess Mike is concerned that when you get a reworking a body and you end up with 500 odd tool bodies, what's going to happen to performance? And I'm not sure if you've got any comments about the type of work we've been doing on our performance testing.
Right. We haven't really. This is one of the reasons why we have architected this application the way I've demonstrated. Imagine, Mike, if you have to build all of them in a single part file. We have seen customers building all the stages. I got example from, the automotive customers. They built all the stages in a single part file, right? Which is very painful. That is the reason why we have architected this. We definitely feel that some of the performance issues they have seen with the current approach they have used to will be improved a lot. We'll have proper, greater improvements with this application. I definitely feel that, but obviously we started working with the customers. We don't have any complaints so far.
Sure. Okay, that's great. Another question is, can you just explain how stage modeling works in the context of Teamcenter? Are there separate items for the operations or separate UG part data sets?
So this one you can see, yes. So we would see in a Teamcenter. Obviously, I have not planned the Teamcenter integration demo today, but we can plan it up later. All of them are going to be stored as the separate revision type. They are managed separately. You would see a stage model set in Teamcenter, and also you would see the stages underneath as a separate item revision. Actually, it's a typical part. We are treating it as this part file, so it's the same way.
Okay, perfect. Yep. Good.
All right. Going into the rule-based PMI. So there you saw the reuse PMI. I was able to get information from different stages, repurpose it. The other important thing is MBD, right? You've seen the demo earlier, but I'm going to show how we are leveraging that in the stage model applications, right? You can see here's an example. This is a final part with all the datums and tolerances and feature control frame information. It does have the node. We built all the stages you can see here. Obviously, I think I used the top-down approach. Went to the cast model you can see at the end. I could have gone ahead and say use the reuse PMI, but in this case we are using this rule-based PMI. Like I said before, we do provide the out-of-the-box 11 different rules under. You can see here I'm going to use a magnify window, so you can pick automation, repurpose, reuse. In this case, I prepared a separate demo here. You can see the stage model PMI, rule-based PMI. I can simply go and insert it. So here, what I'm doing is I'm basically saying, okay, why don't you pick a geometries? What I need is, in this case, this is my final operations. Obviously, I do need datums. I can pick all the datum faces, and I'm machining all those holes. So I can go and pick all those probably 6 or 7 of them. Pick all those holes. So you can see that I'm not reusing. I'm just saying, okay, here are those faces I'm machining, all those holes. At the same item, that's what I care about. Everything else is built in here. If you want, you can even adjust your, the grade tolerance information. If you want, you can even do that. Say 0.15 if you want, or probably 2.5, right? Oops, sorry. It's 0.2. Okay, so once I do this, you can provide, what should be the surface tolerance, the flatness tolerance. That's all you need to key in. When I accept it, oops, sorry. All right, and I accept this one. You can see that it is automatically going to populate. Okay, maybe I was in this. Oh, I was in the wrong stage. You can see that I was in the stage 5. Let me get back to my stage 1. Sorry about that. So I'm going to run this rule again. I need all the datums. I'm going to pick all those holes. Right, when I accept this, you can see that it has captured all the datums that I need, right? And at the same time, you can see this one, the dimensions. You know, you can see this. You know, obviously, I'm mentioning a smaller hole, so you can see this from 5 points. You know, you can see all those whole informations, and the height. You know, the length, width, actually, right? So everything is captured here. I can go into my stage 4. I can again instantiate this rule. In this case, I'm mentioning the center part of the hole. I do need my datums, select all the datum faces, and select my hole I need to mention. So you can see that that's captured here. So I can go into my stage 3. So here I could probably use my reuse PMI. Obviously, this is going to the paint and coatings. I can do that. And I can go into stage 4. I can run this rule again. Obviously, here I'm mentioning all the sides, right, in order to get to the shape I need for the stage 3. So I can go and select all the data faces and also the dimensional faces, the bottom overall dimensions. Right, once I do that, I can go ahead and check here, right? So this is how you could go ahead and, define the PMI. You can see this, how easy it is. So we were able to, we can build the rules. If it has to refer to all those engineering data book or the stock table or the offset tables, the tolerance table, you'll be able to connect to them. I'm sure you've seen that through, Dave Wingrave demo earlier. All right, so this is how you could use our the rule-based PMI actually. All right, so going into my the next part of the process, we got 7 minutes. I'll try to cover as much as I can within the 7 minutes. All right, so again, we tried our best to make sure that the stage model you build here can be directly consumed. Obviously, you're going to try it out. The different customer scenarios are different. Basically, what you could do is within the stage model set, you can go into a particular stage, invoke your downstream application, either a CAM application or the CMM application. The setups are automatically created. And also, if the customers are using different CAM systems, this is like a simple part file. You can use the same, export functions. Everything is available, either STEP or IGS, whatever the customer needs, right? Right. So once I do that, so here, if I go into my stage 1, I'm just going to show you one example. So I can go into my applications. I can basically, I could even create file new. I go into my inspection programming here. So I'm going to look for inspection, right? I can select the table, all the standard template for this inspection machine. Select that. So what it does is, it's obviously going to switch to the inspection application, and obviously you can go and look at the navigator, right? There are no informations here. The important thing is when I link all the PMIs, when I accept that, so you can see that it reads all the PMI from the stage models. You can see all of them here, and then you can see that based on this, the PMI, all the features are extracted. You can see all the tolerance informations are there. And of course, you can also see the inspection toolpath here, right? Obviously, you can go through generating a toolpath if you want to bring in an inspection machine and simulate it. The important thing is it does build the structure for you. You can see that it built an inspection setup for you. It added the stage for the particular stage, and then you can start working on it. Similarly, you can also invoke your CAM application from the stage models, and then you continue on with your CNC programming. Okay, the next part of the process obviously is the presentation is a user experience. You saw some of it, right, where we were able to provide all the stages. We made sure that everything is available in one location. That's why we introduced this new stage model navigator, right? So you see that, how we were able to do that. I'm going to show you some more functions that are available as part of this. The stages are associated. If you're trying to bring in your design changes, you'll be able to update the stages if you need, and also on control basis, like the way I showed, even for the PMI, right? Then we made sure that all the MB3 functionalities are available. I'm also going to show the new compare tool body functions also here. So let me switch to NX here. So I'm going to come back. So if you go look at, I like this example. Let me go into my bracket. All right, so you can see all the, basically this is what I explained to you. So you can look at all the operations in one locations. Each operation stages consist of all the contents required for it, the features, the model views, the PMI. You can also see the rule on the other example, that I ran on that particular stage, right? And we can also look at this as a tree mode. There's a new function we have introduced as a carousel mode. So you can see all of them are available here. Right, so you can see all the preview images. You can also, it's not just this, the image alone. So what you can also do is you can interact with this carousel view. If I click on the circle, you can see that the particular operation is activated for me. You can also use the MP3 on this carousel view, add a stage. You can even edit it. You even want to add a new stage. If you want to delete this, you have the new delete options available. So we're trying to make it, provide a lot more function into this, but I think, you can see the purpose of this. If I'm a manufacturing engineer, I can easily look at this, the preview images, and we will populate a lot more information to this. It does show this, the description that I provided as part of the carousel view, but some customer asked, okay, can I just display it on the carousel view? Yes, we are going to provide that information also. So that's another one. And if I go switch to my tree, we can see that, everything is associative here that you saw. It does show if it dependency span at the bottom. If I click on operation 30, it shows which are the parents, which are the children. It's not necessary that you would always use information only from the previous stage. You can also bring in the geometries from multiple stages into a particular stage, and then you can build up, the shapes on that particular stage also. So in that case, you want to look at your parent-children relationship, right? So it's all captured in one location. That's our main purpose. The manufacturing engineer stays within one environment. Look at everything they need, all the contents, they navigate through the stages, etc. Right? I forgot to show this one, the compare body. So the new tool, I think you are going to see this in detail. So if I have to look at what's going on between operation 20 and operation 10, so I can select one of them as a control body.
Dax, can I just briefly interrupt? I'm just going to say something to the audience. Obviously, you've got a lot of information here. Now, I'm happy for you to run over a little bit, and we will record this session. So whoever wants to stay on, you can stay on. If not, then it will be recorded for you, that you can pick it up later. But I think there's some good information here. I don't really want you to finish early. I'm not giving you 2 hours, but if you want, if you've got another 10, 15 minutes.
No. I think I'll be done by then. Yeah.
Okay.
In fact, I'm also going to provide the licensing information. Martin, you're going to see that. Just give me a minute. All right.
Sure.
Okay.
That's not me. Just carry on. All right.
Paul, just so everybody knows, you'll put the movie will end up on Saba through there, but you'll also put a copy of it up on Highspot too.
I will do. Yeah, exactly.
Right? So if you leave, you can go find it there probably later today to get the last whatever we covered. If you have to go, we understand you have meetings.
Cheers, Scott. Thanks.
Yep.
Right. Okay, so here, this compare body, you can see that, from the operation 20, so obviously in the next operation, I am mentioning this, I think, you see that what is new, obviously between operation 20 and operation 10, these are the new, the feature I'm mentioning. I was able to see it. Obviously if there are anything deleted, you will look at it in a different color. You can configure this color also. And so we basically provided a new window. We can see one with the control body, the source, the sample body, and also we combine both of them, right? You can easily see the before and after state. So you'll be able to go through this sample. So you can see here where I'm going. So I'm going from this flat into all those pocket holes. So you'll be able to adjust this, the sample, basically the translucency between, on a view that have both the stages overlapped, right? So you can look at that. That's another cool function we introduced. Again, what was available outside of stage model, we obviously leveraging everything needed, and then we packaged and architected this to provide a simple environment for the manufacturing engineers. I'm going to keep emphasizing on it. The manufacturing engineers need a tool like this in a simplified way, rather than going to the complex method of, building all the stages. Okay. So let's see here. All right, so that's what you're going to look at it. Obviously you do have an access to this. You definitely love it. And looking forward to a feedback. Anything you may have. So the last part of the demo is obviously okay. It's all there now. Tell me how I can sell it, right? So this is available as add-on. So you can see here, if the customer buys the stage model add-on, he'll be provided this new environment that you saw, right? So far I demonstrated, in terms of defining the stages, the user experience, the navigation, the carousel view, and PMI reuse. The product name, obviously, you would see in the price book is called NX stage models. Another important thing to note, I know that this question keeps coming up every time I present this. Yes, it is available for token also. We need 29 tokens for customers to add this product, in their environment, or work on stage models. The prerequisite is important. The functionalities I covered, you saw the stage model definition, the modeling functionalities, PMI, NX MBD. Yes, you need all of them there. So that's why we have the prerequisite as any NX. If the customer just has a bundle that has got a gateway, it is good enough, but they'll be able to only build all the stages. But if they want to use PMI, they need Mark II bundle. Mark II content contains PMI.
So Dax, let's just clarify one thing. So the MBD product, my assumption was that really just streamlines the creation of the PMI. But if somebody doesn't have that and just is creating PMI manually, it will still work. It's just not the optimum workflow, right? So.
Yeah, that is right. MBD is definitely is a power there. Is a great value there. I agree with you, Paul. But if you have just the modeling and PMI, it way I shown in my demo, right?
Yeah. So Martin, that was my I guess this is a message because Martin has asked the question. Martin Roy has asked the question. Is just to reiterate, whilst you say it's it's a prerequisite, it's to get the optimum workflow for your customers. If we and they want to automate a lot of their processes, the PMI creation, the model-based definition tool. If you missed that enablement, go back and watch that replay because that's really giving you even more things that you can propose to customers. But and important thing is obviously PMI as well is also in the token pool along with stage modules. So tokens is a very attractive way of approaching this. So Dax, I will shut up now and let you finish off. All right.
Yep. All right. Great. Right. Okay. That's it. I think that's that's what I wanted to cover so far, right?
Paul and Dax, should we almost update this prerequisite slide to not confuse the market with the NBD being required to put it for optimal or to automate the PMI creation or something? Put it on there because it's really MBD is not required.
It's the best workflow. The best workflow would use MBD because it automates that whole process versus going through and manually creating it.
But I can add a third line there. We can just say I can do that. I'll modify the slide.
Yeah, I think that's going to cause less confusion in sales processes later down the road.
Okay, right. So so if you have a Mark II with the stage model add-on, good enough to get through the workflow. But if you want to automate the PMI, yes, you need MBD. All right, probably kept saying the same thing. Anyway, all right. Okay, with that, I just wanted to get the slide back. Here you can see this summary of benefits. Again, I'm going to keep saying this. People get the job done with our current modeling and assembly tools. But what we try to do was to make it simple and easy to use, considering the user base who are manufacturing engineers, process planners, no CAD knowledge, very limited CAD knowledge, CAM programmer. They do have a knowledge, but it's different. They don't want to spend on going through the complex modeling process. Rather, they would focus their energy into CNC programming, right? That is exactly the goal of architecting this. Again, as Mike talked about, questioned me on that performance, right? Again, we strongly believe that this new setup, the architecture we have on the stage model, will help come out of the performance issues. The way we create the PM, definition, the stages, it's all focused on improving the efficiency of the manufacturing engineers. Like the MBD, it's great actually, right? You can drive all the rules, capture everything you need and drive the PMA creation automatically. The last one is, of course, we do want to make sure the stage models are consumed directly in CAM and inspection, all those part planning applications, right? You're going to see definitely a lot more, improvements coming forward, but I think we tried our best, we spent like 12 months of development effort on these applications. Definitely customers are going to see the great benefit, the value out of this new applications. Okay, so with that, I don't think any more questions there.
Nothing at the moment. Well, somebody asked, could you please update the slide with the actual token count?
I can do that.
Yeah, perfect. There you are, David. Then we'll sort that out.
Yep.
If there's any others, Dax, that we haven't answered, what we'll do is we're going to take a copy of this and we're going to create a document that we can put the Q&A in, and then that will make that available as well.
Okay.
Sure. For that, and if there's any other questions, ladies and gents, if there's any ladies on, then again, you can always add to this chat or email Dax directly, whatever. Then we can maybe add that information into the document as well. But again, we might well make this a. Yes, Dave. Sorry, not Dave. Sam or Scott, could you add the link to that MBD session, if possible, to this chat at some stage? Well, with that, yeah. Again, I'm sure Dax could have spent another 20 minutes on this, and there was a lot of great information in there. Hopefully, you've got a lot out of this session. I think I have. I think it's it just adds to our overall story. With using the MBD information as well. It just brings more and more of the NX applications together. So I'd like to thank Dax for his time for presenting on this, and I'd like to thank you all for attending. I'm sure you found it useful. I'd say any feedback to Dax directly or in the chat would be great. But look forward to seeing you next week for the
Paul. And I did put the link in there real quick if people want to grab that link now before they leave, so to come back.
Okie dokie. Yeah. So there's the link there is for the
entire
MBD
session. Correct. All the material and the recording and if you missed it. So
sure. Okay. So yeah, thank you very much for your time and attention, and catch up with you guys soon. Thank you.
Thank you all. Bye for now.
Paul.